Hello everybody. Thank you very much for being here. My name is Muhaddasa Maktayfard. I'm the technical support for Sustainable Places 2020. And in a few seconds, we will start with this workshop, the BIM4EEB project. And I'd like to say a warm welcome to our attendees. Thank you for being here. We have a few other workshops parallel to this one, so thank you for choosing us. And the floor is yours, Cecilia.
Thank you. Okay. Okay, this is our agenda for today. I have only to introduce you to our meeting because it's a long meeting. We'll see many of our participants in the projects. We have many interventions, surveys, polls, and I introduce you only to the general meaning of the project and the tools that at this point begin to assume their specific, their value, sorry. In the next slides, you will see, okay, hopefully, okay, it changes. A sort of summary of our tools, where the first is called BIMS because it connected all the other tools, and it is a BIM management system that is an open and interoperable data management platform that enables information to be gathered from different sources in an internet-based environment throughout the building's life cycle. So from this point, that is the connection of all the other tools, you will discover in this talk many of them, not all, but many of them. This platform works as a single source of information for the renovation project and provides a common environment for all the BIM4EEB tools developed by the project. In this way, architects, engineers, and construction companies, technicians, owners, and end users are able to work in a collaborative across all the stages in a building renovation projects. As you see from this slide, the tools connected and that you can manage from the BIMS are BIMeSimulator tool, fast mapping of building toolkit, Autoras tool, BIM for occupants, BIMPlanner tool, BIMCPD tool. The next one is the fast mapping toolkit that is incorporates a range of new tools to speed up the scan to BIM process. We are not looking deep inside this, but we have to say that it works with data visualization of the existing buildings using augmented reality. These are the hardwares that you can work with that are mainly a sensor stick and a headset. The headset is the user interface with the tool, providing all features available. Architects, engineers, and construction workers will be able to use the 3D digital representation to visualize the building, including hidden elements inside walls, such as wall stud, water pipes, and electrical ducts. BIMCPD is the following one, okay, and stands for BIM Constraint Checking, Performance Analysis, and Data Management. The tool is a user-friendly, self-intuitive software suite designed to reduce processing time for constraint checking, increase building energy performance knowledge, and so on and so forth. These are general news that I give you just to have the idea, but we will go through them during our meeting. Okay, the following one that you'll see then is Autoras, that support building services designer to design room automatic system with a semi-automated process of a functional requirement survey and the generation of function block-based designs, which use standardized symbols to ensure a high comprehension from professionals in different trades. The resulting designs can be used directly to form bills of quantities for the procurement process, and this tool imports and reads IFC information from existing buildings. The whole tools work with IFC files. They have assumed interoperability among them as the main key to work on the project. The following tool that we will look through quickly, as we are doing, is a BIM for occupants. That is a mobile application that provides residents, sometimes it works by itself. I go back. Okay. A mobile application that provides a resident and or owners with information related to their building renovation activities performed, as well as with personalized information related to their indoor home conditions, comfort preferences, and energy consumption. The collaborative and user-friendly web-based application consists of two main features, the Occupants 2.0 and the Building 2.0. The first provides access to real-time and historical information about indoor and outdoor environment parameters, as well as information regarding energy consumption. The resident can also provide their feedback regarding their visual and thermal preferences through an easy-to-understand dashboard. The latter facilitates the communication between the building renovation team and flat residents and/or owners. Notification on ongoing works and health and safety instruction can be sent and accessed by the application. And you'll see through that how does it work. This tool, as all the others, are available, of course, in BIM4EEB BIMS, that is the main platform we saw together. The following one is BIMeSimulator, that stands for BIM Early Stage Energy Scenario Tool. The tool is designed to support the decision-making process in the early design stage of the renovation process. The tool allows the assessment of several energy refurbishment design options, enable architects, engineers to provide solutions that best fit to the client requirements, while optimizing the energy use and the indoor comfort of the occupants. Here are the main functionalities. BIMeSimulator enhances the functionalities of the existing sophisticated energy simulation by using the BIM and linked data from the BIMS to enable faster initialization of the actual state of the refurbishing building, resulting in a more accurate modeling. Unfortunately, we do not have the last slide. That is was supposed to be for BIMPlanner tool that provides a digital environment to share up-to-date information about the plans and site progress operations with all participants of the renovation project. Applying the location-based management system, the tool links data from familiar planning and tracking desktop tools with BIM models to allow more effective management of renovation site operation. And this tool also is designed primarily to main contractors and subcontractors responsible for specific site activity, although it can also benefit residents and other project stakeholders that can be notified about the site updates and health and safety recommendations throughout the renovation project. All these tools will be discovered through our workshop today. We have the main actors that worked on that, and they will discuss of the relationship among them and also other teams that we worked on. You have to know that we are in the middle of our project, so this is a midterm conference, and many stuff will be developed after your observation and possibly questions. Thank you so much for all. Bruno, is your time, I think.
Thank you very much, Cecilia. Sorry, Bruno, before moving to the next slide, I'd like to tell our audiences that feel free to leave your questions or comments in the question box, and also there are handouts for you in order to download materials provided by our speakers. And also we will have polls and videos to have an interactive session. So now, yeah, I think Bruno, now you're in control.
Well, I'm not yet controlling, but I try. Good
Can
afternoon,
play.
everybody. Well, I am the coordinator for this project, BIM4EEB, the BIM-based fast toolkit for efficient renovation in buildings. I'm sorry, Mai, but
No, okay, I'll try again. Let's see.
I see your desktop, but I cannot move the presentation.
How about now?
Okay. Okay. Now I have. Okay. Well, just as a coordinator for BIME, just to introduce the project. So the first presentation by BIME, just the framework about the whole project. We have seen that the project is, of course, is a European funded project. 42 months, started at the beginning of 1919, and will go for June 22. We have seen in the previous views that we have a number of partners, 15 partners for 9 countries, 3 universities, Politecnico di Milano, BIME. We have seen UCC, Andre and Brian, and later they will speak about their activity. TUD today is not represented, but they have worked on the ontologies. 2 research institutes, VTT, we have seen Marco and Temu, and we see later, we discuss with them. And RISE, which is working on the fast mapping tool. 2 public administration, the Lombardy region, other of region Lombardy. 4 small and medium enterprise. Here we have here Suite 5 with Costas, 1 team developing the BIM management system, and VisualLink, we have seen Seppo. 3 large enterprise, we have here Pair from CGI, but also Camerion and Prochem, and a big European association. I would thank Larissa, who is managed and organized this workshop. They are representing Europe. We have some focus, of course, in Italy, but we have Solintel from Spain, in Ireland, UCC and IRC, ACE in Brussels, but Germany with the TUD, Finland and Sweden in Scandinavian countries, and Prochem in Poland. Well, the whole consortium has a large participation from the point of view of one side, the stakeholders representatives, which have developed requirements, information requirements at the beginning of the project, and will apply the results of the project on specific demo sites. So there we have a representative for building owner, private and public, Region Lombardy for public, for social housing, and asset and facility manager in Italy, Aller, Prochem in Poland, and Caverion in Finland. And as I told, the architect's representative ACE in Brussels. On the other side, we have, of course, the tools developers, the industrial ones, one team, Suite 5, Visual Link, and CGI, and research centers and universities developing research activity in order to support innovation from the point of view of digital environment for the toolkit. So the toolkit, yes, the BIM4EEB. So the goal is to develop the BIM-based toolkit in order to increase and improve the flow of information during the whole process and gain I'm sorry, but there is still some problem with the flow of the next slide. Maybe boy to, yeah, no, the previous. I try to control, one moment. Okay, now I succeed in controlling. Okay, that's right. So the goal is to improve the flow of information in order to gain time about intervention work of the works, improving performances, quality, and comfort with a specific focus for inhabitants. A specific tool has been developed for fast mapping in order to reconstruct BIM models of existing building in order to integrate semantic data to perform better design options. The final BIM management system will be and is now in the toolkit we will see later, an operational platform as a central repository of information managed as for the common data environment, which is very useful as for the BIM management. So the general objective is maximize efficiency in building renovation, accelerate the market uptake, so the dissemination and communication activities are very important. We have developed a lot of communications and dissemination activities to speed up data gathering and processing, and what is important, interoperability for different stakeholders and tools, harmonizing data exchange formats. Of course, we have worked as much as possible with the IFC format, IFC files, and open formats. The toolkit is now organized like that. We have a central BIM management system, which is developing a list of functionalities. We will see later with one team. Among them, one important thing is to manage and integrate the information coming from the different tools. So on one side, we have, of course, the fast mapping tools developed by RISE and CGI using laser scanners and specific devices in order to gather data from the spaces, but not only, also for materials and equipment parts. BIMPlanner, which is under development with VTT in order to plan the activities for the renovations, and is integrated with this is BIM for occupants, developed by Suite 5, which manage the information taken and given to, with occupants, not only for the works, but also about comfort aspects in the apartments. On the other side, we have a specific activity developed by VTT, BIM Easier, in order to facilitate energy evaluation during the first design stages, we will see later, and two tools dedicated to equipments. The first one, Auteras, is about BACS, and BIMCPD, we will see later. Auteras developed by TUD, and BIMCPD developed by UCC, Cork, in order to manage performances and information for the heating and ventilation, air conditioning, and lighting devices. Well, one of the first activity developed in the project at the beginning was the definition of requirements for managing information during the process. So we have started from the definition of all the activities required, point one, and in order to let's say define which are and point out which are the involved stakeholders, the actors of the whole process to be involved in the whole process. So designers, construction companies, service companies, but also owners and inhabitants. Then step 3, we have defined the most proper information exchange process and workflow in order to point out and individualize necessary requirements which need to be satisfied during renovation intervention. And the final goal, of course, is the final optimization of the renovation process. This will be developed under the leading of BIM4EEB, but with involvement of all the partners of the project. And then for this process analysis, we have started with a definition of the activities, who are the stakeholders, who makes the activities, what are the results of each activity, when, so within the whole process, where we have compared the different approach in different countries around Europe in order to underline possible optimization to be considered. So the final results are reported in public deliverable, which are available on our website, where all the results of this first activity, the requirements definition, has been developed within tables at first to specific flowchart in order to manage activities and stakeholders, with a comparison between the public owner and private owner situation. So comparing our examples from private and public. So the main output are the workflow of the renovation process, in which all the toolkit will be managed with a life cycle perspective for each stages, from the initiative to the end of life. And of course, this is just a portion of the presentation you can find on the website. For specific groups of stakeholders, we have involved external stakeholders in order to define the information requirements. And for this is an example about the construction companies with a survey developed in order to find out the information requirements. Along the workflow, considering the whole supply chain. So designers, client, contractors, and supplier, in order to manage the losing of information in different stages due to not a digitalized supplier. And of course, the goal is to introduce as much as possible digital information and the use of BIM. So for this activity, a number of different organizations, associations has been involved at European level. We see here with a report of about the list of needs and requirements for construction companies to be satisfied and to be taken into account in the development of the BIM management system. So one of the results, this is not all, but just a flash on some results, is about the essential information which has been asked for by the construction companies and used in the organization of the information in the BIM management system. On the other side, a focus has been about the information containers, which are considered to be important at the level of the construction companies, and operating and maintenance manuals and SB drawings, which are very important from the point of view of construction companies. On the other side, we have developed an analysis about our needs and requirements coming from service companies, and we have considered mainly some inputs from literature review, like the Building Renovation Passport by BPIE and other documents, in order to introduce the definition of information requirements related to buildings and equipments and appliances. The final result is a specific definition of a digital logbook with information coming from different institutions. And this is one of the first results coming from the definition of information requirement, but which has been developed within the BIM management system. And at the core of the toolkit is the BIM management system, which is organized as the database, relational, object-oriented, of course, dedicated to BIM objects, but relational and graphical, in order to manage all the information and all resources managed within the BIM management system and in the exchange of data with the tools. And this will be, of course, the goal of the next presentation, to introduce these aspects and the focus, a more technical focus, and we will see also one video for the BIM management system. And the focus now is under development, the agreement and of the BIM management system as for the management of information for the common data environment, using, of course, file, Moodle, container, but also query, as it has been introduced at the standards level by the ISO 19650. And this is one of the efforts we are developing now. Of course, about the whole toolkit, we will have now in the next presentation a full technical presentation of the whole toolkit, where it will be possible to show which are the results, the chief, let's say, the chief functionalities. And in particular, we will see the digital tools for fast mapping of existing building with the help of CGI pair later, and specific tools for managing bugs and heating, ventilation, air condition data using BIM with the help of in this case, a focus on CPD by UCC. The tools for energy analysis with VTT, and tool for inhabitants involvement with the Suite 5. And then a focus about the tools for construction planning and tracking with the help of, again, VTT, but also Visual Ink. Of course, about all these tools, you will see in the next presentation a specific focus, a specific detail, where it will be possible then to understand better which are the development up to now. And of course, all these tools and the BIM management system, so the whole toolkit, will be then applied on the 3 demo sites we have chosen, representing different type of buildings and intervention all around Europe. So considering different climate condition, an Italian pilot in Italy, in Monza, which is from region Lombardy, where there are different interventions for renovation. The Polish pilot in Corso, an ancient one, and then the Finnish pilot in Tampere, where a specific focus will be given on the plants and equipments renovation works with the help of Caverion. For Poland, we have the contribution of course, Solintel and Prochem, the owner and facility manager. Well, this is just an introduction. Of course, at this moment is just to give you the framework of the whole project. And if you have some general questions, otherwise, I would give the word to the next speakers, which are about 1 where we will see a focus on the BIM management system and the functionalities up to now. I don't know if there are some questions. Of course, at this moment, this is a very general introduction, so it's just a framework. So maybe later, when you will have a better idea about the activities developed, it will be easier to for you to give question. Thank you. I would give the word to Davide from one team. Davide Madeddu from one team. Hi, Davide.
Yeah, good afternoon to everyone. The controls will be given not to Alessandro but to Davide.
Yes, sure, Davide. Just a second. Okay, it's all yours.
Okay, perfect. Thank you. Okay, we introduced the BIM management system, as Bruno said before, is the central platform of the BIM4EEB project. Is developed as an open common data environment. Is a CDE to store all the data and information that will be gathered from different sources along the building life cycle. And we develop the BIM management system to a tool to collaborate for every stakeholder that can store, share, visualize the BIM and GIS models, and also some other functionalities that are developed to integrate all other tools that are developed by the other partners in the project. Basically is based on some layers that see the applications with the layers to interoperability between applications and the main database. And one particular thing about the BIM management system, it's about the integration of the new paradigm that is about the linked data, and is one of the first BIM, the first CDE that allows to bring together the linked data inside the resources to manage the information about the building in construction sector. And we have so many functionalities, and here you can see just a brief introduction that we would go deeper after in a video where we present some of use cases. About the functionalities, we've developed a user management, a resource management, and digital logbook, some viewers, and platform to streaming, and endpoints to query, to deal with the data, to gather, and sometimes to put some data inside. About the user management, there's a very powerful functionality with a feature where you can invite user, give to this user some roles, some features, some things that they can do, and other that they cannot do, to give the opportunity for some users to give some private data between other stakeholders. And about the resource management, you will see later more in deep, there is the list of resources inside the BIM management system. All things like documents, models, and so on can see as a resource because can be linked together with other resources. And in same time, we have developed the system, the CDE, take into account all the things that are involved in the standards that in this time the BIM standard is the ISO 19650 about the status of the resources, how can these resources can be changed or shared or published with between the different stakeholders. Another important feature, it's about the viewer. It's integrated an open viewer that allow to see the IFC files to give the opportunity to the user to see the values, the parameters, and the entire structure of the BIM model. There are different 3 views that allow to see the hierarchy of the BIM model, or the hierarchy about the zones of the BIM model, or grouping some items together. This kind of interface, this kind of functionalities allow, for example, to give some features to other tools like BIMPlanner and so on, that you can see later in the presentation. Another important viewer is about the ontology, because the BIM management system supports the linked data. The linked data works with ontologies. The ontologies are about, practically speaking, it's about rules that in a particular domain say what a thing can be linked with another, with a special hierarchy or a special mapping between. The ontology viewer allow to see the relationship between the resources, a relationship between, for example, a window and document that specify the characteristics of the windows, and maybe if in this window there is some activity, some task to be performed, you can see this relationship in an ontology viewer. Another important thing is about the integration of data streaming, about the sensors, because there is a very important role of the inhabitants inside this project, that the inhabitants are able to control the, for example, the temperature, humidity, and so on, the internal condition of their apartment, and they can see how this work in the building, and this data is stored inside the BIM management system, and we have some functionality to see, to query this data, and to give this data to the other tools that perform some specific functionalities. And about the other tools, obviously we develop some API endpoints. The BIM management system is an open environment, and open because you can use the API to connect, to integrate some tools. The project developed a toolkit, and some tools of this toolkit are in development, but in the future you can connect the BIM management system with other tools. And this is a screenshot. It's about how can be used the API endpoint for one of important thing, how a developer and a tool can retrieve, for example, the data from the apartments, and how can this data can be associated with a particular user, and so on. More effort is dedicated to develop this tool, taking into account that the data is more about personal data, because our data coming from the inhabitants, and we take so much care about how to anonymize this kind of data. And it's so much important, this thing, and we develop a workflow that allow to give the data, the personal data, just to the inhabitant, and restrict this kind of information for other users, and all data respecting privacy and the pseudonymization of the personal data of the users. And another important thing is about how we can do this kind of workflow, how we can do these things. And this is more technical, is about very specific technical information. We use, for example, two kinds of database. We use two open database. One is MySQL, another one is Virtuoso, that is a special graph database that allow to work with RDF and ontologies. These two databases are connected together, and this connection allow to have all the important information every time update, and every time you can see the relationship from the graph point of view. And this workflow was not very easy. We put so much effort, for example, in taking into account the batch process that can process, for example, a resource. The resource can be a document, can be a model. In the case of BIM model, the BIM model is translated in database records that can be also translated further in IFC data and structure that can be finally mapped inside an ontology. There are some ontologies to be mapped with the items. The ontology give the opportunity to query the data via Sparkwell endpoint, and after that we see here some relationships from items coming from the model, and also every of these items are related to the others with, for example, sensors and so on, using the specific ontology. Also, finally, about the GIS endpoint, about the locations of things. I will go to the video. In this video, you will see there's a small presentation how it works the system.
Sorry, Davide, it's better if we pause it.
Yeah.
So I'll present it from the back end, so the quality is better.
Okay, perfect, no problem.
Okay, it's about now that our audience.
At first login, the user have a guest role with no access to any functionality. A BIM management system administrator will enable his role, the access to the project and the functionalities needed. Administrators have access to the user and project management to set roles, permissions, project and ontologies. The user's requested roles are visible in the table waiting the authorization by the administrator. He can enable all requests, discard or remove the existing roles. User can also be enabled as administrator too. Project admin can also invite users to a project by email. It can assign roles selecting from a list. All invited users will receive a welcome email and then will proceed to registration as seen before. An inhabitant role is also enabled to be assigned to a building zones. The zones are building location as rooms where the inhabitant lives and will be used to map the user to a set of devices. This is how can be created a new resource in the BIM management system. The most common use case is a designer that wants to upload a BIM model to share the design to the owner or his colleagues. There is a wizard that step-by-step guides the user to compile the data necessary to create a new resource in the BIM management system. We define the resources, selecting the scope, category and typology. In example, we have an IFC model of the building. Then we can compile the title of the resource and description. The user can also set a property of an ontology class to describe the resource and linked data relationship. Then define the location of the resource in a map with a latitude and longitude set as a geolinked data. The resource can also be linked to an existing IFC in the BIM management system. Finally, a file is selected for upload and the status is set. Our resources appear in a resource list where can be filtered and can be managed some status workflow, like changes from work in progress to shared status after a review session or a validation input. From the list can be selected a resource that we can see its detail following the same wizard see before. The resource file can be downloaded and opened in the computer. In the same way, a user can upload other kind of resources like PDFs, images, videos, etc. In this example is a sketch drawing. This kind of resource can be uploaded following the same wizard seen before, but assigning the correct scope, category and typology that allow to classify the items. A good practice can be also set an ontology property for the linked data view. Another example of a resource is the logbook. The logbook stores all the information of the building during its life cycle. It has a specific scope in the BIM management system. The logbook is organized in groups of information with different fields that need to be compiled and viewed by different users like the end user, inhabitant, or the owner or the professional involved in the building. The data fields in the logbook can be written by different users, taking into account their role in the project. There is a set of role permission on the fields that allow to write only specific roles and set a read-only mode for others that are not authorized. This kind of setup is defined to make possible to keep informed some parties while allowing to edit some others. Also, logbook is a resource and can be linked with other resources, ontologies, geolinked data, and will be set with a resource status. As seen before, a resource can be geolinked. There is a specific functionalities in BIM management system that show all geolinked resources created in the project. This functionality allows to open the data to geographical information systems. All geolinked resources contain information about the latitude and longitude set on the resources. The BIM management system have functionalities also to include directly information as linked data, creating resources that can be directly compiled by the users, assign existing ontologies, selecting the classes, and defining the properties for these classes. Storing and sharing so much information needs functionalities that allow also to search a specific kind of resources, filtering by type, description, data, status, creator, and so on. Every resources can be filtered with this field by the users. Another main functionality is the BIM viewer that allows to navigate through the IFC models with our viewer. The viewer allows moving around the model, select the entities, check their properties. A tree view allows to check and select items, looking down the relationships between objects, going through the building, the stories, the types, and the single entities. The right panels show the properties read directly from the IFC file and stored in the BIM Management System database. There are also functionalities to hide, show, isolate, and zoom into the elements selected. The viewer can show the building zones and spaces, very useful to share the data related to the sensors and the renovation works that will be used for the entire BIM4EEB toolkit. A useful tree view allows to select these zones and check the data linked to them. As for example, the sensors measurements of temperature, humidity, and other metering systems associated to the space, and other linked data that refers to the locations like activities, planning, and so on. About linked data, a live SparkWell query is done for the item, and it can show the resources in a relationship with this item. When the data is coming to grow, this will be useful to see the relationships between the foundation of linked data object. A SparkWell endpoint is available in the BIM Management System, where the user can find the resources writing a SparkWell query. The result will be viewed as table, raw data, as a graph, and finally, if the data is related to an IFC model element, can be listed also with the element which are related. This endpoint exposes the Virtuoso database and its functionalities. The same queries could be done by the other tools also via API calls. The example showed a query in the model uploaded in the BIM Management System where we are asking about the name of spaces and locations. The BIM models can be viewed but also downloaded, not only in the original format but also in two RDF ontology types, IFC OWL and BOT ontology. About the ontology, there is a viewer that lists all the ontologies used and stored in the BIM Management System. Graph Viewer allows to see nodes and relationships, their properties and links to the details in the repository. Ontologies can be added and stored giving a name, a URI for the TTL, and a URL for the documentation. There is also a specific page in the BIM Management System web portal that is used to store the KPI. Another section is dedicated for the API documentation. And finally, a page where the user will find the tools, a link for the web page to access to specific functionalities. In this example, you can see how to access to BIM CPD for the BIM Management System through the BIM CPD main page. That's all. Thank you for attention. Yeah, thank you for attention. This is our video, and now could be there some questions, some polling question.
So, hi, here is Larissa from the Architects Council of Europe. I'm going to do the polling questions. So here it's a question that we can hear from the audience. We can have your feedback. So the first question is, which feature should have the actual commercial CDE to improve the collaboration? Select one of the following: better file and folder management, better integration with other existing tools and applications, better IFC and BCF support, better support for versioning and classification. So if you could please provide your answers. Yeah, few more seconds and I will show the results. Okay. Okay, I'm going to close the poll now. David, would you like to comment on it?
Yeah, we expect this kind of answer because as a company that works with some engineers, architects in the market, we see that there is so much to do in about integration, the various tools, application, and yes, also about the IFC integration is another things more expected by architects. Yeah, we expect this kind of answer, and we thank you about that, because it's good to know which are the interest about the market.
Okay, should we move on to the next one? So here is another one. What are the most valued BIM-MS features? So select one of the following: roles and rules management, resource management, digital logbook, BIM model viewer, SparkRail endpoint. So please, yeah, you can answer now. Yeah, we have 52% of the answers. Anything else? Few more seconds. Okay, I'm closing the pool. Yes, David?
Yes, we take care about this information. We thank you about the resource management, digital logbook. Yeah, perfect. Thank you. We will improve in the next months. We take a look more about the resource management and digital logbook to improve so much, to give you the right expectation in the next years about the project. Thank you.
Okay, so we move to the final question for this session. How do you rate the BIM-MS? So very poor, poor, neutral, good, excellent. Please cast your votes. Yes. The votes are coming. Few more seconds. Okay. I'm going to close the poll now. And this is the result, David.
Okay, thank you. Not bad. Thank you.
Okay. Should we move to the questions? I think we have one question here. Is it possible to ask to the presenter under what kind of protection is the BIM4EEB licensed? The question is from
yeah, in this moment there is what about the license? Because as a research project in this moment, the BIM4EEB have an open license, and the features that you see in the video, the BIM management system you see in the video is with an open license. And in the next half of the project, we may develop some other things, but the core of the BIM management system is an open license. If I understand the question, yeah.
Sebastian, would you like to add anything to the question, or is it clear for you?
Larissa, I assume he said no, he doesn't want to add anything else. I got it in the chat. Thanks for the answer, he says. Thank you, Sebastian.
Thank you.
Now we may move to the next presentation, or do you want to further go further with more questions, Larissa?
Do we have more questions?
Let me see. No, at the moment we don't. But then to our audiences, please feel free to drop your questions at the question box at any time. And if you like to be unmuted to further discuss with our panelists, let us know. Just after your questions, you can say, I want to talk as well, and we will unmute you. If you don't have any more polls, Larissa, we move to the next presenter, Brigitta and Per.
Yes, please.
So
Thank you.
Thank you very much,
Hello.
Davide. Hello, Per. Hello, Brigitta. Which one of you should I give the control to?
Start. Brigitta can start, yes.
Brigitta, sorry, should I give it to you? Your audio is not really good.
Yes, please.
Okay, then. It is yours, Brigitta.
So, do you have the presentation? You're running it, or yes?
So yes, our audiences can see the presentation. I believe you can see it too, right?
I can see. Yeah, yes. Yes, we have to move. Oh, sorry, yeah. Okay.
So now the control is yours. It usually takes a bit of time until I give.
Thank you very much. This is the podcast mapping of buildings AR toolkit. And I am Brigitta, working at RISE. And Per, my colleague here, is working at CGI. We are developing this tool together. When we find a picture like this, we know that we have succeeded in our tool. This is a view from the AR tool that will be the best view for the renovation part, that you can see actually what's inside the walls. And the aim of doing this is that new drawings are not always available at the buildings. So when you're doing something like renovations or inspections, this tool can be very useful. So you can actually see the installations. Sometimes, as I said, the drawings are missing in old buildings. So this is a kind of tool that can create a new kind of drawings of the building because of the data you are collecting. And by using the AR tool as a 3D view, you can see the depth in the wall and also a few different layers. The fast mapping of buildings AR toolkit will be developed because of there is needed to know the geometric parameters of the building. We are looking for heating and water pipes. The ventilation systems will be needed to know about, and the electrical cables and materials could also be very useful to have attention of, so you don't get into a wall and hit the installation that can be damaged, or kind of leakage and something. So it's a kind of a safety tool also for doing the right things when you are renovating a building. To calculate the needs of the installation, we need to have a very fast and precise tool. Usually, if you do it manually, it takes a long time. And by this scanning tool and also just the fast managing of the process, you can actually see in the walls very fast after you have done the scanning. You need a sensor stick that RISE has developed, and CGI has cooperated with that by developing a headset tool for the AR augmented reality. What we would like to receive is a lightweight tool, so it's easy to handle and it can be carried out around in the building, and also that it should be easier data format to transfer for the augmented reality. So how do we do this? We like to reach the different target groups like renovation companies, the architects, technical designers, building owners, and installation workers. We think that this is the main target groups, but it can also be used for other workers as well. So this is a kind of a flow chart. How do we do this kind of buildings scanning? So first we do the fast mapping part. We set up a commercial 3D scanner, and we need a good surveyor to know how to do this. It's a little bit not tricky, I should say, but you have to be very careful when you're doing the mapping to get the right geometry, because it's from that you set up your measurements. So what do we do then? We have the workflow with 3D laser scanning set up in the building. The surveyor will be working to just scan the whole building. Sometimes you need to move the scanner a bit, but it's handled very easy. The next part in this is to set up a coordinate system. You create your geometry by setting up a room coordinates by the QR code, and it gives the position of the room and the building. After that, you have the augmented reality tool that you need to calibrate. We use a device called HoloLens 2. It's a quite new developed glasses, and CGI has been working with those development a lot. This device will just be put on your head and will help you to go through the building and actually see a 3D view what we are measuring. When we have calibrated this tool, we start the sensor scanning. I will show you later what it is. It's a stick that RISE has developed, and with that kind of stick, we will detect the installations like stud, electrical cables, metal, temperature, humidity, and also the kind of inductivity and capacity tool. You can combine these to detect the metals inside the wall. Okay, then we see, sorry, I was not finished with that one. So now we are back here. When we have done this scanning, we get the different files in the different data formats. We do the post-processing by cleaning up what we have data collected. It will be done in the point cloud. That also both the laser scanning and the sensor stick scanning are merged together. When we do this interpreting, we will kind of do the position and geometry and get a view over our scanned area. So the data, the different data format will be handling by the post-processing in a laptop. Data from the scanning will be cleaned up and merged into the point cloud, and then the point cloud will contain data that will be transferred into the object, as you can see at the 3D object, and you can visualize it in the HoloLens glasses. When we have done this, the data of the 3D is detected and visualized as a part of the building that you are in. The format after this will be an IFC file that you transfer into the BIM management system that we have heard about before. That data can be handling to create a 3D view of the whole building. So you just combine the different scannings into the whole building. Now it's time for the next slide. How does it look then? This headset is a commercial HoloLens 2 that has been developed into our toolkit, and it looks almost like the one of they had here. You also see the stick, and this is a kind of sensor stick that we use together with a HoloLens. It detects the material, as I said, and this is a kind of view how it could be looking in reality. The most important functionalities that has been developed about the sensor stick is electricity sensor for finding the electrical cables in walls, the positioning function for tracking sensor stick in the real time. The temperature sensor will be useful to detect differences in temperature. You can see maybe in a building, if there are differences in temperature, that could be an indication of humidity leakage or something. Sensors of inductivity and capacitivity to find the studs and humidity inside the walls also. The metal sensor will be used to find magnetic materials. And this is all included in this picture here. When you see my cursor, it's kind of the part you are just sweeping of the wall, and it's connected to a power box down there. I see it more in detail here. You just sweep through the wall, and when you're doing this sweeping, you don't need to put it on the whole wall at the same time. You just maybe a kind of a cross, and also in the upper and down part of the wall to just know that your installations are probably just straight. But you can also choose to sweep it wherever you want on the wall. It's not heavy at all, so this is the real Main thing that it should be lightweighted and easy to handle. So you can just manage it when you have the power box and you also have it in your hand. And the laptop can be placed on the floor in the building. And you have that headset on your head. So now, Per, I'm handing over to you.
Oh, okay. Then you can show the slides, and I just say next slide, and it's easier. I talk when you scan with the sensor stick you show in these pictures. You maybe sometimes you're more interested in what to scan. And for example, if you're interested in what's inside the wall, and if you're getting a hole in the wall between the electrical, where it could be electrical cables, you can just scan a little bit more around the electrical cables where you think it is. And when you scan, you can see, like Birgitta said, some what you're interested in. If you're interested in studs, metal, or water, or hot or cold pipes, and so on, you can scan in this area that you are interested in. All these, when you scan all of these together. So it's when you scan, you can afterwards see what you're interested in. Next slide. Here you see some pictures how you use when you scan. If you scan these walls in the room with the sensor scan, and after you have been scanning, you can show what you're interested in. So here in the example we show, you scan the walls, and when you see the background, you see that it will be some studs or beams who hold up the walls, and that will the sensor stick and the tools will show where it is, and I will show you later how that could be. Birgitta, next. Here is some example when you have scanned wall. This wall you see before, and to handle up this wall, you see that it will be some beams or to hold up the walls. And when you have the glasses on you, you see the green dots here. Then you will see that where it's some green dots, then the wall will be more compact inside. And after that, you can auto-generate from the HoloLens where the beams will be to get the 3D map how it's inside the wall. And I will show you more about that in the next picture. Birgitta. From the HoloLens device, this is the view of the HoloLens device when you're scanning the wall after you have scanned it. And you could just click with your fingers in your hands to get all menus and so on. So it's very user-friendly. And here we take the data from the laser scanning that Birgitta has talked. So you get all the corners, how big is the room, and so on. We put another layer with the sensor stick data that I show in the last pictures. We put on auto generate, and we get a bunch of blocks who is inside the wall. This type it's beams. Okay. No, Birgitta, you can go back. And then after that we put auto generate, and then we generate the beams that inside the wall. We put it inside the wall, And after that, we could take the next step, plaster wall that's outside the beams and so on. And we could create step by step the whole building, the whole room. And when we create the whole room, we get some files. You can see afterwards. Next slide. Afterwards, we have get all the beams inside the wall. That's an example here. We have put it in a room with all the beams, everything inside. We created walls for walls and put it in. And from the HoloLens, we could then create an IFC file from getting from nowhere. We get into the room, like Birgitta say, without any maps and so on. We have seen how big the room is, where all the corner is by the laser scanning, by the sensor stick. We get what's inside the walls. Here is the example by the beams. We can also check for electricity and so on that we have talked. And we create an IFC file. And the IFC file we put into like the BIM management system, like David talked a little bit before about. Next slide. And after that, we have some movie about how we will make this that we will show you. But I think someone in the...
Would you like to display the video, Per?
Yes, we could display the video, or do you have some questions before the video? Or I think it's better to take the questions after the video.
Okay, then I'm gonna display the video now for our audiences.
Welcome to the BIM Companion Toolkit presentation. As many of you should know by now, the precision of the AR tool is based on the precision of point clouds, which is also the entry point of site service. So to start everything off, here are some images of when RISE are capturing 3D point cloud data at their office in Stockholm. And right after a point cloud has been captured, it can be imported into the first part of the BIM Companion Toolkit that sits on the laptop that is brought out to a renovation site. And once the import is done processing, it can be viewed inside the editor. The point cloud can also be transformed in position and in rotation, and as you can see, it can also be transformed in 2 axes at the same time. And rotated. The pivot point of the entire point cloud can also be edited. This makes matching point clouds together much easier. And this is what it looks like when you open up an entire IFC file inside the BIM Companion app. The visibility of items can be turned off or on. And now we're going to create a new IFC file that will be automatically selected on the HoloLens device. And now we're switching over to the HoloLens device. To aid us in our mapping process, we have the sensor stick. and also an Xbox controller. As you can see, Test Street 123 is selected inside the HoloLens menu. Now we're going to go up to the wall and start the scanning process. And this is of course only a short sample that can then be selected inside the HoloLens menu. But before we do that, we need to load and view the appropriate point cloud for that location. One thing to note here though is that this point cloud is captured in Stockholm and the recording site is in Umeå. The different sensor values from the sensor stick are displayed as follows. Capacitance is green, inductance is red, and electricity is blue. And what you see here is a basic blend between them all. The blend can be turned on or off individually. And here is another sensor scan that is a little bit more interesting. But before we look into that, we're going to take a look at the point cloud from within the HoloLens. The point cloud is selected, and as you walk around, the point cloud is streamed from the laptop in cubic chunks. And as I said before, the point cloud that is currently loaded was actually captured in Stockholm, and this is Umeå. So the location does not match perfectly with the point cloud. And now we're going to take a look at what basic geometry generation looks like. And to aid us in this, we're using the Xbox controller. The desired object type is first selected from a list of different entity types. The object is then moved, rotated, and scaled until we are satisfied with it. Multiple objects can also be edited together. That was basic geometry generation. Now we're going to take a look at some more advanced ways of generating geometry that could speed up the site survey process tremendously. Our first example of this is something that we call edge geometry. It works by selecting 3 or 4 corners on an already loaded point cloud. And the corners are found by comparing surfaces on the point cloud and then checking where they intersect. When 3 or 4 corners have been selected, a geometry can be generated. This geometry can then be saved and committed and can also be seen from the app on the laptop. That was edge geometry, but we can also generate geometry using a sensor scan cloud. And this is where we come back to the more interesting sensor scan that I hinted at earlier. It works by clustering sensor values at configurable thresholds, which in this case results in beams behind the wall based on the capacitance from the sensor stick. The result is only to be considered an estimation, and this estimation can then be edited as we saw previously. The result is then saved and committed and can be seen on the laptop. And as a finale, here is a preview of what the app looks like inside a HoloLens 2 device. The first thing that happens is that the user chooses a point cloud to stream from, and then some adjustments are made on its origin. The user then starts the recording with the new sensor stick. When the recording is done, it is given a name using the built-in HoloLens 2 keyboard. The recording is selected and then the workspace is entered from the menu, more specifically the cluster mode. Some values are changed and some beams are generated based on the data from the recording. The result from the cluster is added to the workspace, which acts as a middle layer before committing to the IFC file. Then the user creates a box based on values from the location-specific point cloud. We can then see the newly created box together with the cluster beams in the list that are later committed to the IFC file.
So we are back.
Okay, I will run the first question. So what impact do you think that AR fast mapping tool will have on renovation industry? Select one of the following. Speed up renovation process. Suggest new materials in renovation. No impact. So please, if you could cast your vote. Few more seconds. Okay, I guess we got the results. I will close the poll. And the results are there. Brigitta, would you like to comment on it?
Yes, we're happy with this result. It's the first one that we are aiming to reach, speed up the renovation process. So we think that this tool will help us to do faster drawings and more precise drawings, as we said. Yes.
Okay, great. So just a reminder, if you have any questions, please don't hesitate to put them on the question box. We will go for the second and last question in this panel. So when will the tools be most useful? Select one of the following. In final approval of a new building, when renovating an old building, when demolishing an old building. Please, you can cast your votes. Yes, few more seconds. Yeah, okay. Okay, it's still, the answers are coming. Okay, I will close the poll. And these are the results.
Yes, it's very good results, we think. This is the aim of course, that if you have an old building, you may be missing drawings, and it's also, of course, the main aim to find the installations for the renovation. But I think also the last suggestion here, it can be useful, of course, if you are demolishing a building to make a new one. But the main aim is renovation of old buildings, yes.
Okay. Mohit, do we have any more questions?
So I'm looking. We just got a question from Mika. Mika, if you'd like to be unmuted to ask it directly to our panelists, please just write yes or no in the chat. If not, I'll just read it out. Yes, okay, perfect. Just a second. Off you go, Mika. Hello.
Thank you. Hi, this is Mika Volle from BIMSimulator Finland, and I have a questions. One is you are scanning the old existing building, and what kind of work effort is to do proper IFC model from that scanned information. Last time when I looked such a tool or project, it scanned tons of points, and then it was pretty much useless as an input value, input as a geometrical information, the building simulation software. So instead of shoebox rooms with 8 corner points, it has tons of points, and then the import procedure into the building simulation software was really pointless to do that. So it was much easier to do it from the scratch by hand. So do you have comment on that?
Like you see last time, I can talk a little bit. Like you see last time in the second part of the movie, when we was creating the beams inside the wall. Before that, we have scanned the walls and so on, but just when you create these beams inside that wall and see where there was, it was some movie that was not cut, and it was 3-4 minutes, and after that we have created all the beams inside that wall. And if you make that, so
yeah, I saw that, but I'm not interested in some beams. I was interested in the room geometry, that what is the length and the width and height of that one, and where the actual window is located, and what is the window size. That kind of general information that it's useful for building simulation modeler to simulate the actual room, to get the heating load and cooling load needs, and then make some proper study to okay, if I change the window, what is the new heating load, heating requirements before and after the renovation, that kind of information.
Okay. But then you can see in that part of the movie that we show, we have a simple example where there was no window. But if there is some window, we could put that in and see where the window is, and we create the whole wall in some parts, and then we could put where the window is from the laser scanning data. And I don't think it will be so long so much longer operations to get one wall where the window is than this one.
Okay, thanks.
So thank you very much, Mika. If there is further questions, please drop it in the box. Larissa, can you see any questions? I cannot.
No more questions, but I guess we are on time. We have now 10 minutes break until 4. So yeah, so I guess I'll see you everyone in 10 minutes.
Okay, perfect. See you everyone in 10 minutes at 4 o'clock. We are gonna be back.
Thank you.
See you later.
Okay, in 10 minutes.
All right, I am back. I hope you had a good break. Thank you very much for our attendees that are still with us.
Hi, Mohim.
Hello,
Good
hello.
break here as well.
Yeah, good break. Hopefully next year we see each other physically at Sustainable Places in Milan.
Yes, hopefully.
Of course, everybody, we hope that finally we can succeed to have this. You are welcome, of course, in Milan, and we hope to do it physically. You're welcome.
Thank you very much. Yeah, hopefully we'll see each other, and I assume it will be very good few days in Milan. Okay, so now if Andre and Brian are back. Hello, Brian.
How are you?
Yes, we are.
Good. So I tried to switch the. Should I give it to both of you, the control, or just one of you?
Yes, please.
Andre's going to start off, and then I'll take over after about 2 or 3 slides.
Okay, then it's Andre. Now it's your.
Okay. Right. Okay. So, good afternoon, everyone, again. And in this presentation, we're going to talk about the development of our BIM CPD tool. My name is Andrei Krishenko. I'm from University College Cork in Ireland, and together with my colleague Brian O'Regan, we will just go through this presentation. So my role here, I will start with a short introduction and a brief description. When my colleague Brian will just pick up from me at some point and will guide you through specifics and details. And after that, I will probably conclude the presentation. So starting from here, I would like to say, first of all, that within the BIM4EEB research project, University College Cork is leading the work package 6, where this BIM CPD tool set was developed. Just for those who don't know that, there are 2 UCC groups participating in our project. So first is the IRG and IRC. So I'm just representing the IRG group, which is based in UCC itself. So we were contributing together to different tasks and project activities together with IRC. So the Intelligent Efficiency Research Group, this IRG, is responsible for overall work package activities, while the International Energy Research Center, IRC, which is represented by Brian O'Regan here, is leading predominantly software development tasks. So the IRC has combined these tasks from an efficiency point of view to streamline design and development activities. So they have created a web-based BIM CPD tool, which has different sections to implement each of the tasks. And there is a clear separation between them, even though this tool set is unified and merged under the single graphical user interface umbrella, so to say. The next slide, I'm just trying to. Okay, so this is just a simplified representation of the components of this BIM CPD toolset, where CPD stands for constraints, performance, and data. So as I said previously, with use of common interface, this tool allows to work with checkers for constraints in design and dimensioning for buildings before and during the renovation process. When the system constructed for buildings performance evaluation is assisting and let's say providing the possibility to see the feedback from specific hardware with use of our software to see how those processes of renovation and reconstruction either effective or let's say having specific reflection on the performance behavior, and all of this based on the data being gathered from those sites under reconstruction renovation with data being populated and evaluated with use of our tool set. So next slide here. The following slide, I would probably ask Brian just to continue from this point and talk us through the methodology and the breakdown for those tools available under the BIM CPD, let's say, umbrella. So Brian, the floor is yours.
I'll just do a check there to see I have control. Is that me controlling or you?
Yeah, it works.
Yeah. Thanks, Andre. So what we did in the BIM CPD tool was we divided it into 3 separate tools itself. And the first one we look at is the constraint checking tool, where we would import the floor plans from we say Revit and create the zones for each room in the building. It would also allow us then to identify where the electricity supply board or the air handling unit would start off. And you can see that on the figure on the right there with the purple boxes down in the left hand corner in the utility closet. The main intention for us really was to kind of create recommended areas for diffusers, cable runs, ducting, that kind of thing, and fire detection systems. And as you can see on the image there, we have about 4 zones created and the utility closet starting points. So after some initial configuration in terms of, we say, setting up the zones, you have to set up, we say, the order in which you want to do them in. There's the preferences really is on the user itself, on whether they want to do it by zone, by floor, by the function type of the room, whether it's bedrooms, kitchens, sitting rooms, that kind of thing. The configuration would also allow you to do what order you wanted to work the system in terms of HVAC, lighting, fire detection, that kind of thing. The libraries then that we had, we took a series of catalogs and put those into libraries in our system, and you'll see that further on when we show the demonstration video, which would allow the user more control over what kinds of diffusers were used or what lamps were used in the system. The libraries then themselves allow the user to upload their own catalogs and their own specifications for what systems they want to use. The processing would involve then going through that configuration and finding the best position for those diffusers and lamps throughout the building, and using Dijkstra's algorithm to find the shortest path between all of those. It runs through multiple iterations to find the shortest path, and the shortest path then would lead to, we say, a reduction in cable lengths or ducting that would be required. On the right, you can see the ducting and diffusers as an example of what the system processed, and on the bottom then you have the lamps and the cable runs. After the constraint checking tool has run the processing, you'll get a report at the end, and this report could be displayed as either the layers of the system itself on top of each other, whether it be lighting, ducting, fire detection systems, or sensors. And you could also display them then as a heat map to show, we say, how the airflow, we say, would run in those areas. There's obviously a bit more work to do with this, and as Davide was mentioning earlier from one team, They have APIs to connect, we say, for IFC and the sensors and data and that kind of stuff as well. So to continue this tool over the next 12 months, will be connecting more with their BIM management system to import that data and the specifications and dimensions, because at the moment it is quite manual in setting up the zones in the building, and we want to kind of remove that manual element of it, and that would increase the BIM level of detail as well. Excuse me. In addition, over the next 12 months, we want to look more at the BSRAA rules of thumb, to look at the airflow distribution through the HVAC system to make it more accurate. And then also look at creating a building compliance report for fire safety reasons. So following on from that, then we looked at the data performance tool, and the idea behind this is to allow users to make it easier to select the data that they want to use or that they want to analyze, and to increase the accuracy of the data that they're using by applying outlier detection algorithms such as Grubbs test. And you can see on the figures on the right, where we have a couple of spikes here sticking up on the top figure. We applied an outlier detection algorithm to that, and it identified potential outliers. And the user is fully in control of all of the systems, so they can choose to include or exclude any data that is a potential outlier. And you can see what the before and after effects of that. The BIM management, or the performance evaluation system, has something over 20 odd different types of chart types that can be presented, and that follows the David Abella's, or Andrew Abella chart suggestion figure. So what we looked at is that the user will have options in the system, and you'll see that later on, where they would select, we say, just the 4 types. So whether it's relationship, comparison, distribution, or composition, and the system, based on those options that were selected in terms of variables that were selected in the data performance, would actually output the various different chart types that would match that. So the idea being is that the data would always be presented in the best way to view that potential data. As part of the data performance tool, we have the measurement and verification tool included in that, which will allow users to create a baseline before the renovation or before the application of any energy conservation measures, and then to analyze or to look at that data and to figure out. So the options you see on the right there, in the middle, you can see is a simple linear regression model, and the user has 2 options that when they look at the data, they can see it's either simple linear or change point based on how it looks on the screen, how it's modeled, and they can save that baseline so that when they come back after the renovation, they can run the reporting period analysis, which will give them the approximate savings that between the baseline and the reporting. In addition to that, then the user can also apply non-routine adjustments. So if the building was, we say, 50 or 60% in usage during the baseline, and that changed during the reporting period, that they could apply non-routine adjustments to that data. And that's obviously MV practitioner expertise. The data management tool then would allowed us to store the data in order for it to be better used by the data performance tool. So with the data that's imported from, we say, an API from the BIM management system, or uploaded through CSV, would allow the data to be mapped to our database schema, and we use things like Project Haystack for that to create something that was comparable, that people would be used to using. And what it allows the user to do is to map their data from the columns in their CSV file to our database schema, including all the units, so all the measurements and calculations are done correctly for the data performance. The user, when they upload the data, can view the data to see how it looks before it's actually imported into the database itself. And in the final step of the process there, you can see that once it's uploaded, it's accessible by the data performance system, or the performance analysis tool. And I think that's it. So I think Moha, you're going to show the video on your side here.
Yes, Brian. Thank you very much. Now I try to launch the video for our attendees. Okay.
BIMCBD assigns individual login credentials, ensuring GDPR and enhancing user confidence. The BIMCBD tool provides the ability to store, analyze, and display data in a user-friendly way through a systematic and algorithmic approach. For the data management, files such as Excel, JSON, and CSV can be easily imported with just a few mouse button clicks. The file's data is then mapped easily to SI units. The user then can check the data's mapping before it's imported. With relation to FAIR principle, all imported data requires metadata, allowing for the transparency and easy retrieval from the system. BIM CBD MOV section correlates with the International Performance Measurement and Verification Protocol, and this section is related to another work package. The datasets that are imported by the user or datasets that are shared with the user can be scrutinized through statistical methods, and the outputs are displayed in graph and table format. The system contains various graph methods and various statistical methods that can be chosen relative to the user's needs and requirements. The outputs from these analyses then can be exported for further use. The Constraint Checker dashboard allows for demonstration site floor plans to be step-by-step calculated for the positioning of HVAC, lighting and fire system using best practice methods. Once the floor plan or floor plans are uploaded, they are marked with the HVAC, lighting and fire system panels. They are then split into zones corresponding to the various uses of the property and its areas. Each user-marked area is given a distinct name, and the floor area and the cubic area is calculated for each of them. The user then can either prioritize by zone, by function or by floor, and say which order he wants the calculation to be done. As for items, the database contains a stock number of items for each category, which can be chosen by the user. The user also can upload its own items and share them with other users on the system, thus creating personal libraries for themselves. The final output is shown with the user having the ability to view the varying systems individually or with one another. The ultimate display also shows a heat map exhibiting the attributed output of each of the library chosen items.
All right, great. Thank you very much for the presentation. Very interesting. I found it personally. Larissa, now I assume we move to the polls, yes?
Yes, right.
Yes.
Yes.
No, I just, you know, if that was, Brian, that was the last slide, right? I cannot. You muted, I guess.
Just a second.
Yeah, there you go. Yeah, sorry, it was muted there and I couldn't control it.
Yeah,
Sorry,
yeah.
it was because of the echo on the video. I had to mute everyone else. Sorry about it.
It's fine.
Okay,
So
so
just, yes. So the just a few words to say for conclusion. Just I'd like to admit that those tools were designed to ensure minimal complications for users while maximizing the outputs of each tool. So so through a series of those wizards you saw on the video, the users are guided throughout each process. Let's say we try to design that tool as more user friendly as possible. So just specifically to mention the constraint checking tool, which is designed to include as much references to building regulations as possible, and calculations were made using recommended guidelines. So for users of the system, I'd like just to mention who is the stakeholders we have, let's say, targeted to. They are mostly, let's say, the BIM designers, who will be able to check their model against building codes to ensure they are compliant. They could be energy auditors with use of BIMCPD toolset, being able to conduct energy audits, and this tool will support compliance with the standards EN 16247 energy audits. There could be M&V practitioners with use of BIMCPD tools to execute their projects, as well as administrators who is controlling the renovation processes. A number of functions and system attributes could need modification from time to time, and it is envisaged that these modifications will be undertaken by administrators, so-called administrators, who are familiar with the software architecture. This is it from my side, and thanks for your attention. Now we can go to the pool.
okay, so I will launch the first question. So, which of the following do you think that the constraint checking tool would be most useful for? Select one of the following: MEP professionals, architects, or quantity surveyors. So please, if you could cast your votes. And also, while you are doing it, I would like you to invite to make questions on our question box. So if you have any questions about the tools and even feedback, if you want to give any feedback, please just provide it on the question box. I guess we are almost there. Okay. Okay. I will close the poll now. And this is the results. Andre, any comments, any reaction?
Yes, that's why I was just mentioning those stakeholders being in, let's say, in scope for our development, and we kind of expecting something like that. So all of those professionals, MEP architects and quantity surveyors, more, let's say, MEP than quantity surveyors. Yes, so it's kind of correct, let's say, approach. But as I said, we were aiming the wide auditory with our easy understandable and easy going through interface to make this tool as useful as possible.
Okay, so now we have a last question for this pool. I will run the last question. Would you be more or less likely to apply outlier detection algorithms to your data? Select one of the following: never, rarely, sometimes, most times, always. So please, if you could cast your votes. I'm seeing some votes coming in. Yes, please. Few more seconds. Yeah. Okay. I think I will close the poll now. And this is the results. Andre, any reaction?
Yes. What I would say, it is obvious that as better data we are operating with, as more precise the results and outcomes, which is our final, let's say, aim is to be as effective as possible. So basically, it is not a direct, but let's say indirect relationship between the outcomes and the quality of data we're operating with. And within the BIM CPD, or even within the project, let's say the data gathered from sensors and other related monitoring devices should be stored in the relational database management system. And this data will be accessed by other tools and applications as well, including user interaction data, and it is stored in database management system. So the database will be accessed by the performance evaluation tool of the BIM CPD, and in our case, a series of algorithms will perform the data analysis and will display results in a variety of formats to improve the decision making. So outlier detection as one of those mechanisms to highlight the abnormal situations and cases, and to initiate the closer look, to closer investigation of the causes. Why is that happening? Either faulty hardware or software or mechanisms of gathering the data, replications, and so on. So from our side, I just would like to say that we're doing our best to operate the best possible quality of data. So this is it on my side. Yeah.
Okay, thank you. So the questions, okay, we still don't have questions, but I would like to ask one question, if possible. Sure. So if we have some planning restrictions, so I know in different countries we will have different restrictions. How the tool would deal with that?
I suppose, like for the constraint checking tool, you can build in additional kind of constraints or configurations into that. At the moment, we don't have, like we say, like restrictions built into the HVAC systems itself. But the intention would be over the next few months to add in, we say, obstructions or like things that you can't knock down. So you can actually add items into the system itself, into the plan of zones that you can't mess with. To prevent people, I suppose, from knocking down a wall that they're not supposed to knock down.
Okay, thank you.
All good?
Oh, good. I guess we should move to the next one.
Thanks, William.
Yes, thank you very much, Brian and Andre. So next presentation is from Seppo, Marco, and Kostas. Now I'll try to give you the control. All right, it's all yours.
Okay, thanks. The title of this talk is Towards BIM Enhanced Renovation Management Tools with Support to Stakeholder Interaction. And it will be presented by three of its authors, me, Seppo Terma from Visualink Finland, Marko Kiviniemi from VTT Finland, and Kostas Tsatsakis from Suite 5 Cyprus. There are also two other authors who have worked, contributed to this work, who are Rita Lavika from VTT and Spiros Kousoris from Suite 5. So I wonder if I can change the slide. For some reason, my control doesn't seem to work. Okay, now it's okay. It's probably been too far. Okay, so the problem that we are addressing here is the following. So residential renovation projects often take place in buildings where occupants continue to live during the renovation works. And also, renovation projects are characterized by additional uncertainty caused by the surprises when the old structures of a building are opened during the construction stage. And the presence of occupants obviously create a need for communication to coordinate the actions of contractors and occupants and to ensure proper health and safety procedures. But in addition to that, this uncertainty about what the building contains and the consequent changes during the execution of the project, the communication needs to be dynamic and flexible. And it cannot be based on like static plans circulated in the beginning of the project. And our goal here is to achieve this kind of smooth coordination between these stakeholders using BIM Enhanced Renovation Management System, which is based on linked data and ontologies, and have targeted and dynamic interactions between different parties. The picture in the bottom of the slide kind of captures the essential concepts of our approach. So we have activities which are defined using location-based planning techniques that can be linked to apartments which are associated with BIM models, and apartments again are further linked to occupants and owners, and this makes possible to establish this kind of link of communication between things that happen at the activity side to what happens with the occupancy side. And in the BIM4EEB toolkit, this renovation project planning and management is carried out by a system called BIMPlanner, which is shown here at the left side of the figure, and the communication with occupants is done by the system called BIM4Occupants, which is at the right side of this picture. And both of these systems share information through the BIM management system, shown here in the middle. And now the primary users of BIMPlanner are the contractors, and the primary users of the BIM4Occupants are obviously occupants. And these three different systems enable the coordination between contractors and occupants. And the concepts behind these tools are based on shared ontologies, especially IFC ontology and digital construction ontology. And next, Marko Kiviniemi from VTT will give an overview of the BIMPlanner system.
Okay, hello. Very briefly, BIMPlanner is a project management software where we try to recognize the needs of the renovation projects, and it is intended to be used for the detailed planning and also tracking the site operations. The background there is based on so-called work location-based management, where we define those work locations with BIM. But besides trying to improve the fast-track methods for renovation projects, this is also a project to get some proof of concept for how to utilize the linked data, and all the data is stored as RDF data following the DICO ontologies that are developed in this BIM4EEB project. And I have a few slides. Here is the first one. In the lead construction management methods is some kind of a set of principles and methods to improve the productivity at construction operations. One key issue there is that it is thought that there are such flows that can be considered in previously like resources that are needed to implement an activity at site. And of course, there are several types of those flows, but in this project, we are concentrating this workspace. So all activities at site, we are dividing by the work locations in order to be able to track that, to divide the activities in a smaller parts or shorter duration tasks to be able to manage the process at site. And this this is the use scenario of this BIMPlanner tool. We are expecting to have some kind of master schedule for the project existing that sets a target for the detailed planning. We upload that in a system. There is a possibility to define more detailed activities, divide those master activities in some subsets. And also very important issue is to define the work location with the 3D BIM view. The most important part of this procedure is this weekly planning. It is intended that each week, the next week is planned at detail level, how the work is proceeding through those work locations. And each week there is also defined the statuses of ongoing activities. We assume that this would provide up-to-date information of the work progress at site, which allows shorter lead times between activities and better transparency of the site activities to all stakeholders, to all subcontractors, but also to the possibility to share the information of work progress to the occupants. And of course, this detailed weekly planning is not enough. There is need to make some middle-term planning, and those sub-activities and also the work locations may be detailed during the process. And of course, as we have this data existing in our backend system, there is a possibility to retrieve different type of progress reports. And as said, this is a semantic picture. Below, there are some classes and properties of these DICO ontologies. We populate this ontology with some activity, schedule, time, data, and also link these activities with BIM object, IFC objects in IFC model. And as I said, this all data, the activities, and this IFC data is existing in RDF format in graph database. And the idea was to share this information of the site activities to the occupants, and the BIM for Occupant software tool is intended for that, and Kostas may continue from here.
Okay, hello also from my side. Going to the details of the BIM for Occupants application, which is the applications for the occupants, as stated before. We have two types, the building owners and the building inhabitants that needs to get access to the system. The scope of this application is wider, considering also what we are presenting now. We will focus now on the interaction that is taking place between the BIMPlanner tool and the occupants that are actively involved in the project. So the idea behind this application is to allow end users, building users, to get actively participating in the definition of the renovation processes. And for that reason, together with the building occupants that are involved in the project, we co-designed an application that fits their needs. Following a typical methodology for defining the architecture of the solution, we proceed with the initial requirements analysis as extracted through questionnaires with end users. We define the architecture of the application. We circulate it then back to the users the mock-ups for the final use of the application in order to get their feedback. And then we proceed with the development and the deployment of the application. Highlighting, so the application is a typical 3-tier application that enables visualization of information, of knowledge coming from the middle layer that operates over the data that are stored in the backend of the system. Two critical things that are presented also in this slide is the first, the interaction with the BIMS platform. The central element that was presented also at the beginning, which is responsible to handle all information through this linked data framework that we are envisioning in the BIM4EEB project. Special focus for this part of the functionality, the incorporation of the decontology that was presented before, the details about the renovation processes that are to take place and how these data are transformed into knowledge for the application. In that way, our application is able to retrieve in a personalized, let's say, way, information associated with the renovation process that will take place. So this is the first core part of the functionality, how to retrieve data from this linked data framework that we're developing in the project. And on top of this, we have the layers of features that are supported by the application. So after discussion with the stakeholders, with the building occupants, we have three sets of functionalities that are provided by the application. The first is the scheduling and operational planning, how the building occupants can get involved in this process and define, along with the BIM planners, the different renovation processes take place. The second thing is security and safety on site, as we highlighted in the document. As you know, the renovation processes are tightly linked with some alert situations that are taking place in the premises. And of course, the building occupants, as the active users of the building, have to get informed about these situations, or even further being able to report this situation to a central platform. So we have also this part of the functionality supported by the building BIM4 occupants application, while also as an add-on we give the opportunity to the end users of our tool to be able to update information having to do with BIM enhancement, as we name it. That was a critical task for us because it's difficult to go to the building occupants and somehow persuade them to upload information. So through the interaction with the users, we defined a set of information that makes sense to be uploaded by the building occupants. Having done this, so here in this slide we're missing an animation, so I will try to explain a bit the different functionalities provided by the application. We have defined these 4 layers of the application, 3+1 layers. The first part, it's not clear now as all the screens are presented now, is about the renovation process management, where details about the start time and time duration, some artifacts associated with the renovation process are presented. The part of safety and security alerts, which is the list of safety or security related messages that are delivered to the users, with some annotation having to do with the time of the event, the typology that we are considering in the project, the history of the events, and so forth. The part of BIM annotations enhanced with the 2D visualization of the premises, of course, in a personalized way, giving the possibility to the users to access the information that is associated with their role and their, let's say, credentials. While also a notifications feature is an add-on on the application, where as most of the activities performed by the app is under an event-based mode, we trigger these notifications to the users in order to properly notify about updates performed in the application. Saying some more words about the validation that has been missed from the previous presentations, it's good to say some extra words. We have 3 buildings that are under recruitments under preparation for the validation of the project activities. Among them, the tools that were presented during these presentations are to be tested in these buildings. Actually, I will say that this specific functionality that was presented will be tested in 2 of the 3 buildings, highlighting this plug-and-play framework that we are envisioning in the BIM4EEB project, considering that not all the functionalities, not all of the applications are going to be tested in all demo sites, showing also this adaptability that a specific end customer, let's say, or a building can validate or test or incorporate some of the functionalities that we are delivering in the project. Most important is the part of the validation process that we are following in the project, also applied for this application. Of course, we need to have at the beginning a good understanding of the buildings that we are to apply these technologies, the first phase of the project, and further modeling or incorporating in the BIMS platform all the details associated with the elements or the materials that are to be considered at these buildings. So now we are in the process of having all this information incorporated in the BIMS platform, and further all the interrelationships among the different elements, entities that have been specified in the project through this linked data framework. And now we are in the progress, as in our application, to integrate with this BIM central platform and start gathering data, or even being able to push data back to the platform. So for the next phases, which are the critical, also mentioned before, for the project success, is of course the possibility to gather the data that are required for the analysis, to extract the knowledge or perform the functionality, as in our case envisioned for the BIM4EEB application, and then proceed with the implementation in practice of the renovations activities and further operation of the building in order to be able to test the functionality envisioned for the different tools, in our case for the BIM4EEB application. That's it. I mean, there is a last slide, and I give the floor back to Mark to present this last slide.
Yeah, perhaps I can continue. So, basically what we have here, instead of presenting one tool, we are actually presenting 2 tools from the this BIM4EEB toolkits that exchange information between each other through the BIM management system, and this the development of these tools is still ongoing, and they will be validated in the pilot sites in Finland and Italy especially. And we have some observations so far. So we have been able to express the required links in the ontologies and convert the plans to the link data that comply to these ontologies. We have noticed that it creates some requirements for surrounding systems and practices that need to support this kind of planning methods, so that we, let's say, BIM models should include spaces and zones, so that we can properly use the location-based methods and make these associations with apartments and occupants. When we have a lot of link data, we have we tend to have a lot of different kinds of user interfaces to manipulate that, and to create these kind of methods. They are not really all there as of yet. And also one bottleneck in developing this kind of software is the basically lack of software development tools and skills. So we are really at the early stage of developing this kind of linked data software, but we see it as a promising enabler for future renovation management systems. Yes, thank you.
Thank you very much to our presenters, Seppo, Kostas, and Marco. And now, Larissa, I think it is time to move to the video.
Before going to the video, just let's say as a disclaimer to say that for the BIM for Occupants tool, we presented as part of this presentation part of the functionality provided by the BIM for Occupants tools. In the video, we are incorporating, or we are presenting, let's say, the full functionality of the BIM for Occupants application. So for the first part of the presentation, the focus is at the operational phase of the building, where, as presented at the beginning of this session, information about the environmental conditions and the comfort conditions in premises are displayed also by the BIM for Occupants application, and also energy-related information having to do with energy consumption during the operational phase of the building is also presented through this BIM for Occupants application, and thus the video demonstrates the almost full functionality provided by the BIM for Occupants application.
Thank you very much, Kostas. So without further ado, I'll try to display the video.
This is a presentation of the BIM for Occupants tool, the tools for the inhabitants and the owners in the BIM4EEB project. As the first view, we have the login page, where we provide a credential first for the inhabitant. By logging into the system, the user, the inhabitant, gets an overview about the environmental conditions in premises through the sensorial equipment installed. So we have measurements about temperature, humidity, illuminance, and air quality. Also outdoor conditions from the region, while also giving the opportunity to the user to set its preferences, its settings about the current comfort state. So the user may select and provide feedback that will be further used in the analytics engine for the extraction of dynamically updated comfort profiles for the building occupants. Along with a view about current conditions in the building environment, we have the historical view. At first, we have some statistics which define the boundaries of the user for thermal and visual preferences, while also we have the history of data about the environmental conditions. So the user may drill in, select a period for the analysis, and get insights about previous environmental conditions. Along with contextual conditions monitoring, the user has access on the Energy Analytics tab in order to get insight about his or her energy consumption. Along with the time series view with details about energy consumption at a specific period of time, the user gets some overview data about the selected time period, while also time filtering functionality is provided for the user to drill in to specific time frames of interest for visualization. This is the first part of the view associated with the profiling engines delivered in Work Package 6. The second part of the presentation has to do with the active participation of inhabitants in the renovation management process, work performed in the context of Work Package 7. So a first functionality for the user is the ability to get insights about the activities, the renovation processes, the tasks to take place in the building environment associated with its apartment, its zone, and also get some extra insights about these activities. A calendar view is also accessible in order to get a quick view on the history of the activities performed in premises. Along with the renovation processes, we have a tab where the user gets also insights about specific safety and security conditions. Once a business stakeholder is triggering a new notification and alert situation about the building environment, the end user of the tool, the inhabitant, is getting notified about this situation. Filtering is also supported from the app in order to have a quick lookup on the different types of events triggered by the system. In addition, the inhabitant has also the possibility to create a new safety incident. The user selects from a list of predefined types of safety events, a topology that we are following in the project, the type of importance, and some extra information in order to update this information to the central platform and make this information accessible to the other business stakeholders, for example, facility managers or constructors. Last but not least, the user has the possibility to get insights about specific objects associated with its premises. So here we have the list of devices associated with the spaces of the apartment, and thus the user may select specific space and get insights about the devices placed there. Also, the user has the possibility to enhance the model of the building by defining new elements, providing some meta information, following once again the typology defined in the project, and that way updating this information to the central management platform of the project. Extra functionalities provided for the inhabitants are the administrative view, where the user has its role. In our case, we have the inhabitant role for the specific user. We have details about the profile, where the user may set some parameters, may update the password or delete the account, and also giving the possibility for the end user to provide personalized names for the different elements. So the user has the possibility to change the name of the building, of the apartment, or of the room in order to have a more personalized presentation of the information. So by updating the name of the apartment, we have here the update also on the name of this specific BIM element. Notifications are also available for the users associated with the renovation processes and the safety and security condition. So once a new event is triggered by the platform, a notification is posted to the user in order to have a better lookup on the different updates on the renovation management, and also localization support as the application will be delivered to the different demo partners, and thus it's good to support also this functionality. By logging out from the inhabitant role, we log in to the building owner as the user of the system. Similar to the inhabitant, the owner has aggregated view about the contextual conditions in the building environment. So the building owner gets insights about information at the level of the building or at the level of the floor. Also, the same applies for historical data about the environmental conditions and for the building level energy analytics, while also personalized views are accessible from this user, the owner, on the management of the renovation process. So the view is similar with the view for the inhabitant, though the information is associated with its role, the role of the owner. By logging out to show some final list of functionality supported, of course, the users will sign up at the beginning of the demonstration activities by the unique user token defined in the central management platform. And of course, the user, once creating an account, they have the possibility to change their password in the case that they have forgot their password. So by providing the username considered during the registration process and the user token, the user has the possibility to update the password information.
All right, great. If the speakers don't have any further comments on the video, Larissa, we move to the next poll. Am I correct?
Yes. So the next poll for this session. So we have two for this session. So this one is, what is the main obstacle that hinders building occupants' participation in the renovation process management activities? Select one of the following. Lack of interest from building occupants to participate, lack of lack of understanding, from building occupants on renovation, lack of interest from professionals to have building occupants enroll in the renovation management process. So please, you can cast your votes. We are receiving the votes. Okay, few seconds more. Okay, I'm closing the poll, and these are the results. Any comments on that?
Yes, it's something that we're expecting to get as feedback. Of course, the least possible answer is the lack of interest from building occupants. Though it's difficult for them to understand the concept, which is the most probably case as it happens now, may show some interest in order to participate. It's the fact that, I mean, it's a complicated task to have them enrolled in the process, and that's a major, let's say, bottleneck on this process. And of course, it's the lack of from the professionals, where there are, I mean, limits on the way that they consider the role of building occupants in the overall process, mainly related to the lack of understanding. So it's something that it's something that you can easily understand as an answer from this poll.
Okay, great. I guess I will move to the next one. So, why is communication a bigger problem in renovation than in other constructions? So select one of the following: coordination between contractors' activities and occupants. I'm sorry, I guess we don't have the full the full answer, but I will read it to you. Coordination between parallel activities of contractors and occupants are needed. Occupants need to search for the previous drawings of the building. Occupants mostly take place in indoor spaces. Activities mostly take place in indoor spaces. Surprises when structures are opened create uncertainty and cause changes. So if you can cast your votes. Okay, few more seconds. Okay. The votes are coming through. Okay, I will close the poll. And these are the results.
Yes, I guess it's also kind of expected. So I guess the in renovation, especially residential renovation, the parallel activities of contractors and occupants at the construction site. This is the main reason that there is need for more communication and more like active communication. Second is that there are this uncertainty because there will be surprises when structures are opened. Just yesterday, a friend of mine told that they have they're like apartment building some additional work worth of €1 million because they discovered something during the renovation work there. So it's these kind of surprises is the second reason for that.
Okay, so I guess this is the pause for this session, and then yeah, I don't see any more questions. Mohi, do you have anything from your side?
No, Larissa, at the moment I don't see any questions, and I think we are on time to move to the last presentation.
Yes, please.
Yeah, I would love to ask to our advisory board to look in the chat that I wrote them privately. That's all.
Yes, please, advisory board, look at the chat. So thank you very much. Next is Timo. I'll try to pass the keyboard to you. And there you go.
Or good evening. That maybe depends on where you are. So my name is Teemu Vesanen. I'm from VTT, Finland. And my presentation is named Early Stage Energy Refurbishment Assessment Tool for buildings using high-end BIM data. And let's see if this works. Yes. So when we are talking about buildings and energy and assessments, one might easily think that we are creating an energy simulation program, but that is not actually the case. So when we are talking about BIM assisted energy scenario tool, BIMeSimulator, that was developed in this project. The focus is in a process and a tool for managing the linked data and the BIM to assess the energy performance of those buildings. And more of that in the coming slides. So there is some very sophisticated energy simulation tools commercially available, and there was no need or no idea to reinvent some of those. So we selected one. We have been using IDA Indoor Climate and Energy, which is made by a company Equa, and we also have them in the advisory board. So from my point of view, it's a good tool. I think many other people also think so. It is common in at least Nordics, maybe also in Germany and Austria, maybe not that much in the Southern Europe, but you can have a look at the web page later. Key question for those energy simulation tools is how to get input data for those. And in the traditional design process, the amount of data is increasing all the time when the process goes further, but still there is the gap that you can see in this picture. So we can go quite far in the design process, and there is still missing data that there is problems in using the simulation tool as we don't have all the required data. And the scope of the BIMeSimulator tool is to solve this problem of the gap, so help collecting the input data for those sophisticated energy simulation tools and needs. To say a bit more about our tool, so it is used during the design process, and we have called the user with the role name Energy Expert. That can be a separate profession, or maybe it is the HVAC designer, or control system designer, or architect in the process who can take this role, but someone should take a responsibility of that. And the main focus in the process is in the early phase of the design. So idea is that when we do something automatic, it focuses on the early phases, and then later when the design goes further, then there is all the details are available even without these automatic systems. The main functionalities of the tool are to build an as-is model, so how the building is when the renovation project is started. That's the basis, of course. Then we apply some renovation scenarios. So those are the set of individual measures that are applied to the building, or they are considered that maybe we could change windows, and maybe we could add some insulation, or maybe we could add some photovoltaic panels. So those are the scenarios which we assess, and then to compare those scenarios, which one is the best one, we calculate some numbers which we call owner's project requirements. So the building owner can use those and see which scenario is the best one with his or her preferences. So some owner might see low consumption so important that the system can cost a bit more, and some other owner maybe thinks that the cost is the most important, and then everything else is secondary, and then they can select based on that. That is the basic principle of the tool. So in the middle you can see the energy expert who represents this design team. So everything should be collaborative, and energy expert should discuss with the design team. In the left hand side you can see the BIM management system. That is the basis in our BIM4EEB project. That is the place for the BIM, so the IFC in practice. That is also the base for the link data, so other information except the IFC that could be used in the energy simulation. Then we have created a building energy simulation data model. So that is a common format using the linked data and ontologies to bring the data to our BIMeasor tool, which is there in the green border. The BIMeasor tool also gets some input information from these renovation measure databases that we have created in this project. So that database has the cost information and that kind of information from countries. How much does it cost to buy and install those photovoltaic panels or something? The BIMeasor creates the renovation scenarios and sends them to our simulator, which in this case was IDAIS. IDAIS sends the simulation results back to BIMeasor tool, which then calculates the OPRs, which are there in the in the bottom right corner, and these go then back to the design team, which then can suggest or they can also be stored in the BIM system for further use. And design team can of course then propose the best scenarios for the building owner. These are the currently calculated OPRs. There could be also something else, but we started with energy savings, comfort for the occupants. So overheating is currently calculated, and then these different costs, of course. So there is delivered energy, primary energy, and share of renewable energy as separate indicators, and then these overheated hours and investment costs, operational energy cost, and payback time. And then the owner can value these as he or she wants. Some weighting factors can be put to those and then selected which scenario was the best one. Our user interface looks like this. So everything is packed into single screen. On the top left corner, you can see these external connections. So this means that here you will set your account into BIM system, BIMS, the BIM management system that you will use to select the project here and get the information. Then there is also definition of the simulator. So IDAs in our case, and then base model in the IDA system that will be used for those simulations. Renovation measures are here below, and also those scenarios are defined here. These will be seen better in the video. And on the bottom part of the screen, there is a table of these OPRs that are calculated when the simulation is run. So to conclude, the benefits of our tool is that it allows accurate buildup of those as-is models using BIM and the linked data from BIM management system. And it is usable in the early design stages where most important design decisions are made. So if you can make the decisions in the early phases, then it's much easier to select those and maybe make some changes to the plan. If the process goes further and decisions are made in the end, then it's much more difficult to change anything, and it gets easily costly. It also allows easy application of renovation scenarios to the as-is building. So when these predefined measures are available in the national database. And it also allows collaborative work inside the design team. So idea is that the system works so fast that it's possible to leave it running, go and have a coffee and come back and then get the OPRs ready. And then the design team can discuss what or how the different options look like. Of course, we also have some challenges. So as always, the simulation depends on the quality of input data. And also with the BIMeasure, the accuracy of the tool relies on availability of good quality BIM data. of those renovated apartment buildings. Then it's always balancing between simulation time and details of the system. So if there is large buildings and they have many simulation zones, so there are different parts of the building that are separated in the simulation so that you can get energy consumption and temperatures and conditions for every room, for example, then it easily gets quite heavy and the simulation might take too much time that it could be run in that coffee break. But maybe the balancing and experience on how the model should be planned helps on that. And also simulation tools are developing all the time. They are going into cloud, which enables much more calculation power than the current versions that are run in the laptops. But that's my presentation about the tool briefly. So I think next there will be a video just to demonstrate it a bit, and then we can have the questions and discussion about this.
Yes, thank you very much, Timo. Next, as Timo already mentioned, is the video. We shall try to launch it now.
In the BIMeSimulator main page, you first need to log in, create a project, connect to a simulator. Currently, the testing has been made in IDA-ICE. In the end, you will need to load a base model of the assessed building. In the right-hand side, you will create a new scenario, a set of measures. And from left-hand side, you can drag and drop renovation measures into the scenario. After the scenario has been defined, it is time to start and run the simulation for current scenario in the connected simulator. Owner's project requirements are calculated from the simulation results. In the table, you will see them calculated for each scenario. Finally, it is time to publish the results into the BIM management system using the Publish button. The results are transferred in an ontology format. A Sparkle query can be used in the BIM management system to verify that the results have been successfully transferred.
All right, let's follow the tradition and move to the polls. Yes, Larissa?
Yes, so we have 3 questions for this session. I guess 3 quick ones. Let's start. So, is your work affiliated with a residential building renovation business? Yes or no? Please cast your vote. Okay, we are receiving the votes. Yes, I will give a few more seconds. Okay, I will close this poll. So these are the results, Temo.
Yes, it's good to say that we have a lot of people that are doing the same thing that was in our project focus, but also that we have over a third of those that are interested otherwise. So that's also good to see that you have lasted this long with our presentations.
Okay, great. So let's jump to the next one. So do you think BIM has a role in the residential building renovation? Yes, already today. Yes, in the near future. Not in the near future. No, not in 5 years. So could you please cast your votes? Yeah, we are still receiving votes. Okay. Okay, a few more seconds. Okay, I will close the poll. And these are the results.
Yes, great. At least our audience trust BIM and we are doing right things in our project.
Okay. So great. So the last question. Do you think the concept demonstrated with BIM easier tool is feasible? Yes or no? Please, you can cast your votes. We are receiving the votes. Few more seconds. And then just a reminder, so all the videos you saw in the presentation, they are available on BIM4EEB YouTube channel and also on our BIM4EEB website. So if you want, if you would like more information, just visit our website. I will close now this poll and the results.
Yes, thank you for the trust.
Good feedback. I guess this is all.
Yes, that's all. Thank you.
Thank you, Teemu. Thank you all. I think we are close to the end. Is that correct? And we are looking for more questions if there are. The afternoon passed with many ideas. We had the opportunity to explore situation in the middle of the project, and we had an interested audience. We want to take advantage that there is part of the advisory board connected to have some impression that we know then if they become concrete observation are fundamental to proceed with improvement of the project. I don't know if there are some, perhaps Mika Rekola said me that he could give us some impression or any present here.
Yes, there are present, but then if the advisory board, I'm addressing you, if you would like to be unmuted, please use the tool raise hand, and I immediately unmute you to speak. But then I don't know, maybe they have left their laptops. So let's wait a few seconds. Okay, Mika wants to speak. Hello, Mika. Thank you for being here.
Thank you. Thank you for this opportunity. I was positively surprised and the comprehensive approach that you have in this project. And now, after all the presentation, there's very first slides in this session. Now they are became much more clearer to me about the whole process. It helped me understand it now, and I think that this is a right way to do it. There are a couple of one highlight for me is this, that there's this renovation measurement database with all the prices, and including not only the price tag of the actual product, but also the labor cost and stuff like that. That's really valuable. It's very reliably seen, and it's very rare that it's open. The one question is that open for other participants ones as well, that if somebody wants to have a connection to this kind of database. And other thing is that came my mind, as Teemu already pointed out as well, that it's the quality of the data. Even if this data flow is working nice and smoothly, the outcome is always sensitive to what are the data we have there in terms of quality of that it's really present the actual building, and it's made correctly, and also even if the data flow is working, that in most of the cases there might be still some mistakes in some percentage of the model, and it will fail that transfer the data between these different tasks. So some kind of quality control is very welcome to these ones, to see that once people are submitting something, or for example somebody's adding these renovation cost in this measurement renovation measures database, that there are right numbers in right currencies and stuff like that. So these are the first things that came to mind, but very comprehensive approach, really good work. I like it. This was useful for me as well to be in part in this workshop. Thank you.
Thank you, Mika. Thanks a lot. Is there any of us that is ready to reply to these? This would be great. I don't know if Teemu or Bruno, any of you?
Well, at least I can say something.
Please go, Teemu.
Yes, so the first question was about those renovation measure databases. So currently they are part of the deliverable, which is confidential. So, but of course we can discuss about that with you or with anyone else, Mika, if you are interested. Mainly they are now made for the piloting purposes, so BIMeSimulator tool will be tested in Finland and Italy. So we have filled in some costs and measures for Finland and Italy, not from other countries. About the second question about data quality, I can just agree with, or at least agree with you, that this is very important question, how to ensure the data quality that we put into those databases and storage systems.
Yeah.
Okay, Teemu, the database is really interesting for IDAS customers to have that one. And if you are not ready, and this is confidential information, what are the actual numbers are there, but you have had definitely you have to make some serious thinking. What is the data look like? So if you can share the database columns, so to say, what are the columns here, what are you will feed there, and in which format. For example, PV panels, are you calculating the cost with PV panels divided by PV panel area, or what are your measures there? So these kind of thinking could be valuable for other persons as well, even if you are not publishing the actual price tags.
Yes, so we did some research how to do that. There is some information available about that in the project. We just need to think how it could be published or reported or otherwise exploited. So maybe we can get back to that in the coming meetings with the advisory board or other project meetings.
Thanks, Teemu. It would be nice.
Well, I just say I fully agree with Teemu. We have to discuss internally what can be used as a public. At the moment, we have a part of data which are confidential and they are developed within the framework of the project. But of course, the cooperation with the advisory board and the feedback from the advisory board is important. So I think in the next, we will find some opportunities for exchanging information, and in any case, to take into account any proposal and discussion with the advisory board. So maybe in Finland, we have this good opportunity to have some members from the advisory board connected with VTT. We can start a first, let's say, discussion about these feedbacks. So I think, and the same with the other members from the advisory board. So if there are other comments from other members from the advisory board, they are welcome. I don't know if there are. Cecilia,
I assume we have one more from Mirka. Mirka, if you'd like to, I'll unmute you. Hello, Mirka.
Good evening. Do you hear me?
Yes, yes. Thank you for being here.
Thank you for the invitation. I was unfortunately only able to see basically the presentations after the coffee break. I was able to join late. But thanks for very interesting presentations. I think you have a wide variety of aspects that you are looking at and lots of interesting tools coming up. I also have one question to Teemu, which would be that, are you considering how you present the results to someone who is then making the decision? Now, I felt a bit that your demo was stopped just at the point when it was getting interesting. If I was the building owner, and I think the tool sounds very good if it makes it easier to compare several scenarios for renovation. But how can I understand the scenarios and how will they be presented for the selection?
Yes, thanks for the comment, Mirka. That's a good one. We had specified that our target user is the energy expert. So we were thinking that it's the energy expert that who will then present the results to the building owner. But maybe we could better help him or her in doing that. So creating something more visual from those results, so that it would be easy to discuss and understand.
Okay, thank you. I think that would be interesting. And I maybe a little bit similar question to the tool that was for renovation management and the occupant communication that Seppo and Markku and Kostas was presenting. I think there the problem is really relevant that the building users need to be informed very well about what is happening and when. When you were talking about the location-based management and stuff, did you consider that you could also use this to somehow present the activities to the user? Because then the user tool that was presented was more focused on safety issues or something like that. But maybe if one question in your questionnaire was how to, or the question was not how to involve the occupants into the management, but maybe they could have something to add there. There would be potential to maybe involve them. And if you could show in an interesting way how what is happening and in which parts of the building or something like that, maybe they would be attracted to follow more closely and give input also. Did you consider that you could use the BIM and location-based stuff also for the user involvement?
This is Markku Kiviniemi from VTT. If I comment that is an interesting point. Mostly we have been thinking about very detailed level planning of site activities in order to notify beforehand the occupants of the coming activities on next week, in order to be able to, that the occupant would be prepared that what will happen, will there be something disturbance and so on. But the idea of this kind of to involve the occupants in, let's say, somehow in the project level or even some midterm level planning, to get the idea that what would be the good way to utilize the, let's say, the knowledge of the occupants of the building where they have been living for a long time. And in some it might be for example, the owners benefit that the occupants that will of course have some disturbance of the renovation could be pleased that they are involved in this process. But actually that kind of a approach we have not thought about, but we shall think about that.
Okay, great. These were maybe my main comments and what I noticed about the presentations.
Thank you very much, Mirka. If there is anyone else from the advisory board that would like to talk to our panelists, you can, on the control panel, there is this option, raise hand. You can raise hand and I will unmute your audio. If there's no one else, Larissa, I think we can just conclude.
Yes, I would love, I'm Cecilia speaking, to thank everyone, but I don't know if Bruno then has to add something. So at present, Bruno?
Yes. Well, I would thank everybody for the participation on this conference today. Of course, the members of the consortium, but all the participants. And we will have now the activity of testing this toolkit on the demo site, and we will involve again the advisory board for the demonstration of the toolkit on the demo sites and to have your feedback for the future activities. So I would thank, of course, also the organization of the consortium of the workshop and Madi and R2M for this good organization. Thank you, everybody. And see you in the next.
Thank you very much, Bruno. Cecilia, Larissa, if there is any conclusion.
Yes, the
and our
conclusion
panelists.
From my point is that we want to wish everyone that the next conference will be in the sunshine of any of the countries that we represent here. So thanks to everyone, and let's hope for the best in the future. Larissa, do you want to add something? Also, my thanks to Moi and Larissa for her management at all times of day and night in these days.
Thank you, Cecilia, for your kind words. Yeah, thank you, everyone. Thank you for all the effort. Thank you for the attendees, and yeah, hope to see you soon.
Okay.
I'd like to say my thanks as well. Thank you to our panelists, Cecilia, the chair, and Larissa for your support. And our attendees, to our audiences, feel free to share if you had any more questions afterwards or comments with us. You can always email sustainableplaces@r2msolution. And also, if you'd like to know about our other workshops, tomorrow is the last day and the closing of Sustainable Places. You can always follow us on Twitter, @SustainPlaces, I guess. And yeah, thank you very much and have a good evening.
Thank you.
Bye-bye, good evening. See you.
Bye-bye.
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 Bye.
Bye.